Hey, I'm doing a video on angular momentum principle. The problem states a figure skater is spinning at 10 radians per second with her arms extended. Her rotational inertia is 2.50 kilograms per meter squared. After pulling her arms in, her rotational inertia is 1.60 kilograms per meter squared. How much work does she do to pull her arms in while spinning? So we have our givens first. We write down those first, and the initial angular velocity is 10 radians per second. The initial rotational inertia is 2.50. The final rotational inertia is 1.60. So in order to find the work, we first have to find the final angular velocity. I'll bring you through those steps. So we use the law of conservation of angular momentum, which states that the angular momentum initially equals the final angular momentum. And we use this law because external torque is 0 and the angular momentum as a result won't change. Angular momentum is equal to inertia times the angular velocity. So we set the initial equal to the final. We're trying to find the final angular velocity, so to get that by itself, we divide by the final inertia, leaving us with this. We fill in it with our givens that were stated in the problem, and we end up with 15.6 radians per second. Now that we have that, we can go on to find the work. The work is the change in equal to the change in kinetic energy, the rotational energy. And we use rotational kinetic energy because the figure skater is spinning, so she's rotating. So the change in kinetic energy would be K final minus K initial. Since it's rotating, it's different from in previous chapters where you will use 1/2 mass times velocity squared. Instead, we will be using 1/2 inertia times the angular velocity squared. And for the initial, we fill in 2.50 as the initial inertia and 10 as the initial angular velocity, leaving us with 125 joules. We do the same thing for the final, we just fill in different givens. So for the inertia, the final inertia was 1.60, so we put that in. And we found, this is why we needed to find the angular velocity in the previous problem, so we can plug it into the kinetic energy final. We multiply all these numbers, giving us 194.7 joules. The last part of the problem, in order to find the work, since the work is equals to the change in kinetic energy, so we do kinetic final minus kinetic initial. And this leaves us with 69.7 joules. And that is the work that the figure skater does to pull her arms in while spinning.